Good evening, ladies and gentlemen. As Julian said, my name is Higgins. I work for CSC. I've been working for CSC for probably 7.5 years as a data and solution architect. During that time, my main role has been lead data migration architect, initially working on the NHS account, and I'm responsible for designing and then building the teams to develop all of the data migration, data extraction and data migration technologies that we use today on the NHS account for migration into our Lorenzo single strategic instance. When Julian asked me to do this, the topic was healthcare data management. Obviously you all know data management is a very large topic to talk about. So what I've done is I've actually chosen a small subset of areas which touch upon a lot of aspects of data which may be of interest to people in the room. What we're going to cover tonight is effectively four areas. So healthcare data migration, so this is challenges and lessons learned from what we've built at CSC for the 9 or 10 trusts that we've got live today on the Lorenzo instance. A little bit about validation as a service, which is an offering which allowed us to effectively improve quality by empowering the health organisations themselves to build data sets to improve the quality and the throughput. So we'll talk about that. Reporting services, practical design, just to talk about what we do within reporting. There are various aspects of reporting and all clients have different requirements. So just a little bit about reporting services. And then just a little bit about what's coming up. So I've moved now into global healthcare. So globally we're looking at what we can do outside the UK. And a lot of that now is around predictive analytics and big data and coordinated care, especially in the States. So we'll just touch upon that a little bit. But before I do, just very briefly, I've got 1 minute on Lorenzo. That's all it is, simply because we migrate into Lorenzo at the end of the day from a migration point of view. So what is Lorenzo? It's our single strategic instance solution. It's an integrated EPR system. So it was originally developed in line with the specifications of the National Programme for IT, but as you probably all are aware, there were a lot of contractual changes with the government, and so originally we were expecting a single view of the patient across the country and we bring everything into this single instance. As it happens with the change in the contract, we aren't getting anywhere near the buy-up from the health organisations that we originally did. So it's a single instance that can support data sharing across the local health communities. So what that means is that we've got around about 10 that are live on this instance at the moment, but they can work in isolation and their data is not visible to any other health organisation within the instance unless they want to choose data sharing, and then we can merge the instances so that multiple health organisations can see that data. It's hosted across multiple CSC data centres so that we've got zero downtime and full disaster recovery. And it supports patient care in acutes, community, PCTs and mental health. So from a data point of view, what are the aspects of the data? So it's built on top of Microsoft SQL Server and it is partitioned around the patient. So not only do we store the patient, but we store all the transactions for that patient within the same partition to try to improve performance of retrieval. It's a single master patient index. So we store all the patient demographics. They will be stored separately, but if they decide that they want data sharing, then we can merge those records together. And it's very much focused around security, around not allowing that data to be seen by health organisations or anyone that hasn't got access to it. So role-based access control, legitimate relationships, smart card access, etc. It's integrated with other healthcare systems through HL7 messaging, through desktop integration, other types of interfaces. It's spine connected for patient demographics, allergy information, etc. And it supports national data sets, so health organisation data sets and medication nomenclatures, various types of reference data. So that's all I want to say about Lorenzo. So in terms of the data migration itself, what I want to talk about are, again, it's a very broad topic. I just want to take a few selected areas to quickly discuss. And they are the client engagement process. So we need to get answers out from the clients as to what they want to migrate at the end of the day. Some data transfer mechanisms for discussion, data mappings and business rule discussion, a little bit about reference data translation, and how we identify errors within the system and how we resolve those errors within the system. And then a little bit about the solution itself, and finally, just a typical data migration operating model that CSC deployed. So if we look very quickly at client engagement, something I forgot to mention, we've got 4 sections to this. Rather than storing all the questions up to the end, what is probably best is we'll finish each section and have a set of questions. That way people remember the questions if they want to carry on. Yeah. So just let me finish the section on data migration first though. So first of all, we need to understand the scope of the data to be migrated. So sounds straightforward. So from CSC's point of view, what we do is we have a number of file specifications, around about 250 of these that are defined. And they're broken down into functional areas, and around 20 functional areas, so patient identity, referrals, inpatient, outpatient, contact management, mental health, accident and emergency, etc. And then within those functional groups, it's further subdivided. So in patient identity, you would then have core details, so your name, your age, your date of birth, your marital status, your religious status. We would have aliases, next of kin details, addresses, IDs, etc. So what we have is around about 250 file specifications of the data that we're going to migrate, and different hospitals take different flavours. A mental health institute would require the mental health data sets, others would not require that. So that's breadth, and then obviously the depth is within that as well. So reduced data scope definitions. Again, I say that sounds easy. So for instance, let's give you an example. People say we want the last 2 years worth of data. Sounds nice, but it isn't practical. It isn't practical just to deliver the last 2 years worth of data. If I've got a patient that was registered 4 years ago, but their referral is a year old, if I only took the last 2 years worth of data, I would end up trying to load a referral for which there's no patient associated. So there's a hierarchical structure, you define the rules, and then you build up the hierarchical structure to extract all of the data that's associated. And that's where reduced data scope comes in. Now, if we take something like Morecambe Bay, when we did Morecambe Bay, 600,000 patients, 4 million addresses, etc., 100 million records to do in about 12 to 18 hours in a deployment. So you can see straight away that reducing the scope of the data might significantly speed up the deployment itself. Next, data ownership sharing. So obviously you've got to agree with the health organisations who can see the data, because you get people like data migration analysts, data loaders, who are going to have to see that data to load it, because they're generating the errors. So there's an agreement there. Availability of source subject matter experts at the health organisations, a real problem for us. They've all got the day jobs, but during migration they need to be fed in to actually help with the low-level data mappings. Define the process of data cleansing as well. We're coming on to that a little bit later. Defining the infrastructure and the tools. So do we have a Lorenzo single instance, or in some cases where we've got data residency issues where the trust do not want to release their data into a data centre, we have to build an on-premise solution, so we have to bring all of the tools in associated with that, data migration, extraction tools, etc. What reports are required to the clients? The biggest challenge there is reconciliation reports. Proving to the health organisation that whatever we've migrated in, we've actually delivered to Lorenzo. So that's a challenge in itself. And finally, a little bit about the test data considerations. If we're building a migration solution, they don't want us to use the live data. We therefore have to build anonymised or pseudonymised or use synthetic data. So again, that's a challenge, because you need to ensure that every bit of the data is anonymised. So it's not just things like addresses and names and dates, but also any text fields, any free text fields. They may have reference to a bit of patient-sensitive data. So understanding client engagement is fundamental to this process. Then what we've got, a bit on data transfer mechanisms. So over on the left-hand side we have the source data systems. Some of the systems, CSC, already have legacy systems sitting in our data centres for. Others will be brand new systems which are not CSC legacy systems, McKesson, other systems that we know nothing about. So that's on the source side. Target Lorenzo we're migrating into. But fundamental to our solution is the definition of these 250 intermediate flat files or data sets as we call them. We've said there's 250 of them. They actually define, if I give you an example, some of these data sets can have about 120, 150 fields within them. The data types are defined, the business logic and validation rules are defined within the specifications, the transformations are defined, and the target mappings are defined. So everything's defined within that file specification to allow a tool to take the data from source and map it through into target Lorenzo. So if I look at what we've got today, taking out of source, we've developed tooling to do direct extract and load through from a CSC data center hosted solution like ISOC Patient Manager. But for those which aren't hosted within our data center, the hospital themselves, the health organisation, is required to build the set of data sets that they want to load through into, migrate through into Lorenzo. For that, we actually work closely with the health organisation. So it's not a case of just build it on your own. We will provide support and the specifications to allow that information to be derived. They can derive it however they want, SQL Server scripts, whatever. It's just that they have to deliver those data sets. Also, if you think of migration, we might be able to message some of the data across into Lorenzo. We might be able to script it. Some of the data will be direct data entry. If you've got clinic reorganisations, new types of wards, some configuration at secondary or tertiary level, that will be directly entered. You've also got the case where maybe you don't want to migrate the data. The trust want to say, right, we'll start off with a brand new Lorenzo. In that case, a few things to think about. You might build desktop integration in, which allows you to switch back to the old system to look at historic data, but you've also got to consider archiving strategies, decommissioning strategies. All of those need to be considered as well. So in terms of the mappings themselves and the importance of the business rules, we have the specifications, and as I said, within the specifications we've got around about 3,000 business rules that are built into those, some simple, some complex, checking the data and the data quality, and those are built into the tools themselves, so all of those validations are done against the data. So it's a well-defined set of specifications. It's geared to the target Lorenzo, so that is where all of the validation is done. Within Lorenzo, we have application and database constraints which prevent data from being loaded if it breaks those constraints. If we look at what we've got to do, so low-level data mapping, that's why we get involved with the subject matter experts at the hospitals. They understand their source data. They have to map that with our help into the fields within the IFFs, within the dataset specifications. Gap analysis is something else that has to be considered. What if there's data which is sitting within the source systems and there is no placeholder in the IFF for it? So we've got value in the source which isn't going to move. Yeah, so you have to assess that. Similarly, on target, you might have placeholders in target, Lorenzo, for which there is no data. And sometimes that data is mandatory, so you have to work out what you've got to put in that target Lorenzo. Reference data translation we're going to talk about. Internal data linkages, sometimes a problem because you've got 200 data sets you might be creating. You've got to make sure that all the reference between those data sets is correct, otherwise you're going to connect the wrong referral to the wrong patient, etc. And reference back to legacy data records. 2 years down the road, someone might say, where did that data come from? So we also make sure that when we migrate the data across, we always keep a pointer back to the legacy system. And one point to note here is the auto-generation. When we built this solution, originally it took 18 months to 2 years to build the full 200 data sets. It was quite a complex undertaking. However, through auto-generated solutions, after learning from the fact, it took about 3 months. And now all of our, whenever target Lorenzo schemas change, the application team just, the data architect team feed that into the application team and the data migration team, development teams, and they then change the specifications, and that auto generates the new set of tools for us, so we don't have to worry about that side of things. We come on to validation around identification, and what I've just said is lesson learned auto generation. Right, reference data translation. Right, this is quite a difficult area for us. Every health organisation we go to has defined a lot of localised codes. And in Lorenzo, we have a national data set, and we expect those localised codes to map through in the main to the national set. So there may be at the national level a specialty of general surgery, and locally the trust might have created foot surgery and leg surgery, but they're not part of the national set, and we conform to the national set. That isn't to say that in a lot of cases we don't allow transformation, but what we do is we build what we call data capture sheets and local code mappings, which allow us to do the transformation between specialties. Separately, we have reference data, a large amount of reference data, 20 or 30,000 different items, and we have to maintain a translation table, because in Lorenzo you have something called a concept code, which is a value which might be male, female. Source systems in the Netherlands, male is M, female is V. So M becomes male, V becomes female. So there's 20,000 plus chances of having to set up the reference data. Now, with new health organisations, we've got a starting point now, so it's easier. We're also looking at master data management, trying to build this solution now so we can actually publish that out to the various teams, so not only ourselves in data migration, but also the messaging team, the configuration team, so we have one standard set of reference data. Error identification. So what we've said is, here, within the tools, we have 3,000 plus different sets of business validation. Things like you can't be 3 years of age and married, you can't be 300 years of age, you can't be born, your deceased date can't be before your birthday, etc. So some are simple, some are complex, some are combinations of composite as well. But all of those are built into both my extraction tool and auto-generated into our load tool. So out of both of these feeds a set of errors. Now what we've said is 100 million records, we feed them through. We don't just identify the first error in the record, we identify all of the errors within the record. Otherwise, when you go out to the hospital and they fix the first, you then come across the second. So they're all identified, so we have the ability to warn and pass through, because when we push the data through, we have a set of dependencies, parent-child dependencies. So for instance, if you don't load the patient record, if you try to load the referrals, they'll fail, the inpatient data related to that, etc. So we have this ability to warn and pass through. That's what we do on our very first engagement with a health organisation, is we set everything to warning and pass through and run a quick check against the data. It gives us a feel for how good the data quality is. We have to cater for orphanage and cascade issues. Orphanage is true orphanage. It might be in the source system, a DBA's gone in and they've done something and they've deleted a patient and they've left all the referral data there. That's true orphanage. Cascade issues are where you may get when you're doing true validation, the patient record fails, but the referrals come through. Again, can't learn patient without referral. Again, target validation for duplicates, that is for deltas. So if we migrated some data, 100,000 patients across, we get another 10 patients to load, we have to do some check to identify whether the patient is a duplicate. If it is, any of the transactions need to be attached to the existing patient within Lorenzo. We have a mini data warehousing structure for reporting. It's a very simple fact table with about 4 dimensions around it, which allows us to roll things up. So if we process 4 million addresses, we don't want to give the trust 4 million address errors. We want to say we've got 4 million errors rolled up as one error code with maybe 10 as an error threshold to deliver to them to have a look at. Data correction. So what do we do with correction? This is a big problem for us, because if we go back to a health organisation and say, there you go, we've done the data quality assessment, there's 300,000 errors you've got to fix. If they don't fix them, every time you run the process, you get the same set of errors. So, but by the same token, they've got the day jobs and they probably haven't got the time to fix 300,000 errors. So what we have to do is work with the health organisations, maybe implement, there will be certain error types which have large volume, and we can maybe implement a default or some value or some rule which will fix those on the fly. Source or metadata. If you fix it in the source, very unlikely it's going to get fixed. There are some tools out there at the moment which have very nice visual front ends, and what you can do is you can sit down with the hospital, when you've run the reports through and you've got the errors, you can go through and you can actually go in and define some rules and some profiles within the front end. It changes the metadata within the tool, it doesn't change the source, but you keep that metadata. The next time you load the data, it applies those same rules, therefore fixing the problems. We apply defaults, so I've already mentioned about mandatory fields, which you have to have in Lorenzo. If there's no association, we provide a default for it. And again, the ability to warn and replace. So if we're in go live, if we've agreed rules with the health organisations, we can actually load that data straight through by manipulating it within the tool sets. This is the last but one slide. So these are the solutions that we've got available, very, very briefly. And as I've said, 100 million paper, 100 million records, expected to be done over about an 18-hour period on a go live. If we look at Lorenzo, the first thing about this is we've already got 10 health organisations that are live on the system. If we want to migrate the 11th, we can't switch those 10 off, which means that we've got to do it while those patients are live. So we've got to do it in a way that reduces and that prevents us affecting the end user response times. So what we've done is we've defined an address range within Lorenzo. So all of the transactional data through the Lorenzo applications and through messaging, etc., is written from 600 billion downwards. So there's a transactional data address range. So everyone in the user space is using this data. What we've got above that is a load of space. And we create these silos for each of our hospitals that we're migrating to. It allows us to migrate in whilst users are still using the system. So we have CSC hosted data from source, bring through, extract it, identify reports, push it through into data sets, load it. So the load tool preloads, undertakes validation. The validation is associated with business rules. That will then generate all of the errors. We'll transform it. We transform it to look like the schema in the target, and then we load it directly. How am I doing for time? One last slide. So a typical data migration model is, so obviously we identify the issues, we have to do these many times. So right at the beginning, and to give you an example of timeline for this, within CSC, if we have a data center hosted legacy system, IPM, that's sitting in our data center, a typical migration will be around about 9 months to deploy. And that's because of the data quality issues that need to be resolved before moving into Lorenzo. If it's a non-hosted solution, typically it's about 12 months. And that is because the quality of the data, I think I missed a slide. But anyway, that's because the quality of the data is normally pretty poor. No, not pretty poor, I won't say that. What tends to happen that we found in the old source systems is, over time the quality improves, but data which is, let's say, 10 years of age, there may have been old migration processes that were done, so the data didn't conform to check constraints, so anything was thrown in. There have been application changes, all sorts of things happening, and therefore the quality of that source data is not necessarily as you would expect it to be. And that is why we need to go through this phase. So what we do is initially, after the hospital engagement, we do a data quality assessment immediately to find out what the quality of the data is. And then we work with the organisation, the health organisation, to work out how that data gets corrected. And we run through that until we've got a good set of data. At that point, it comes into pre-trial load. We run through it once just to make sure that data is of a fairly good quality. And then we go into trial loads. The idea is to get the best set of quality data that you can when you start the trial loads, because what you want to do is reduce the number of trial loads. You don't want 15 trial loads, you want 2, 3, 4 trial loads. Each one of these trial loads is around about 6 weeks. It's normally broken up into a week of extraction, a week of loading, 2 weeks of both user verification, CSC verification and hospital verification, and 2 weeks for fixes. But it's not a fixed 6 weeks. We'll have a 6 weeks, but there will be a gate at the end of it, which says, I've just identified 500,000 issues, you have to fix 75% of them before we next start the next trial load. Otherwise, you just capture all the same things again. So it's gated. We go through all of the trial loads, and eventually then we get into dress rehearsal when we've got good quality data, and then eventually into go live. Go live, the deployment is over a weekend. We can't switch the hospital off for long periods. They obviously need their systems, but they do normally go to paper for a weekend. The data migration is normally about an 18-hour window, but with all of the additional deployments associated with setting up messaging and the new systems that are needed, it's around about a 48-hour period for deployment. And as you can see at the bottom, we start off with on smaller DM environments, and as we progress through to dress rehearsal becomes similar to the production environment, so that we can gauge performance and scalability as well. So all the testing is done at that level, at that point. So that was a quick run through. I think it's probably worthwhile, while it's fresh in your minds, to generate any questions if you want to. I'm quite happy if you don't, but...
Okay, perhaps you can tell us what the main reasons would be for a health organisation to migrate. Okay, so then what they're seeing, what they're having to get out of it, and a second question, in some cases the source of data will be paper-based rather than on an electronic system.
Yes.
Are you able to handle that in some kind of incremental way?
So normally a lot of the paper-based information, to some of the hospitals I've been to, they've got large scanning departments, and they've literally taken paper which is 4 times, 5 times, medical records, 4 or 5 times the size of this room, and they're scanning them all one by one, and then creating electronic records of them, which we then pull into the system. So for a paper-based system, if you don't do that, you won't have them on the system, you'll have to keep them, but that's what I've seen from a paper-based system. In terms of why migrate? Well, first of all, there's the discussion, whether it be the CSC Lorenzo, or be another solution. It's, you know, what have you got on the old system, and what does the new system give you in terms of additional functionality, better business process than the old system. So first of all, there's a management and business decision to be made as to whether that product is better. If it then is better, then it's the case of discussion on the migration strategy. And as you saw on one of the slides about the migration strategy, there are multiple questions to be asked. It might be that the hospital say, I don't want to migrate anything. I'm going to take the new solution, maybe a clinicals only or a full PAS and clinical solution, but I'm not going to migrate any historic data. I'll start again from fresh. I'll keep that system online, and I'll use that for any historic data. or I'll build a desktop integration solution which points to it. And then there's all the challenges associated with, as we said, with what do you do with the archived data. If you keep it online, you've got to support it. You've got, and that's a cost in itself. Do you decommission it? If you decommission it, you've lost it if you haven't migrated it. So there's sort of a halfway house which is where the reduced data scope comes in. How much data do you actually need? What we tend to do is say, we migrate all, a lot of health organisations say, I want all open referrals and I want the last 6 months worth of closed referrals. And what you do is you use those referrals to move up the tree to identify all the patients that you want to migrate, and down the tree to identify all of the activity associated with those patients, and then that's what we migrate.
Thank you for the presentation. I thought it was very good. Well,
we've only started. There's another 3 sections.
Sorry, actually, you mentioned that the hospitals go to paper systems at weekends. That might need to be reconsidered because I believe there's a lot of pressure being put on hospitals now to run a 7-day-a-week service.
Yeah, it's part of the discussion. As part of the process initiation, there will be a lot of discussion about the deployment mechanisms. But it's almost impossible to go for, full uptime switching from a legacy system to a brand new system. Yeah, I mean, we have looked at the refresh process for deltas. So migrate everything up until, where are we now? We're in November. So migrate everything up till August onto the new system. And then and then as a second migration, take everything from that cut-off point to now, which is all new patients and all new registrations, plus anything that's modified or updated. But actually to do that and to apply those updates to the data sitting in our system actually takes longer than doing the full migration, because updates take far longer than inserts, generally. And especially inserts we do, because we're migrating 100 million records, and because it's SQL Server based, it's using, under the cover, it's using basically a bulk copy. So it's just that data's just flying in there. Yeah. So and updates take a long time to do. There are strategies though, and obviously every health organisation is different. So it requires that engagement and that discussion.
Thank you.
Do you think awareness about data quality is the need for data to be of good quality is growing in the health sector?
I think it is, but it's part of, as you see from the deployment model, it's the first thing that we talk about. It's always the first thing. There always are a great number of records that have got quality issues, and we can't migrate. Some organisations, especially in the global healthcare space, what they do is they just switch the constraints off and throw the data in. Yeah, and so they say that they can migrate everything in. They don't have a 9 to 12 month deployment timeline. They have a 2-week timeline because they switch everything off and throw it and throw it in. Within Lorenzo, there are a lot of application and database constraints built into the product. If we just throw the data in and switch it on, half of the records won't be visible. Yeah, so you have to go through this quality gate.
Can I ask a question about reference data, which kind of ties into the thing about data quality in a way? The process of introducing reference data where previously there have been local or legacy coding systems.
Yeah.
Some of that's a quality question, and some of it often there'll be situations where the reference data you want to introduce is more constrained, and the risk is you lose some of the local flexibility that people have got out of their legacy systems.
Yeah.
So how do you introduce the national reference data while still giving people kind of, you talked about if they've got foot surgery and ankle surgery rather than just orthopaedics. Yeah. How do you give people the utility that they got from their legacy systems whilst the consistency that you get from national reference data? And is your national reference data continually refreshed, or what's the process for maintaining that once somebody's migrated their data into it?
Yeah, so if I take the second question first, which is the reference. So at the moment within the UK, the NHS has got their TRUD website. So we go to the TRUD website every so often. That's technology reference data update site, and they've got about 60 data sets on there, and we only load about 7 of those. So health organisations, care providers, dentists, a few others. But we go to that. We are implementing an automated process which should pull it down daily, but I don't think it's updated daily at the moment.
It's only monthly
It's probably every 2 or 3 months at the moment. So that answers that question, and that's pulling that down. We've also got, you know, all of the so the SNOMED, so the nomenclature of medicine and the ICD and the OPCS data, and all of that we need to keep updated as well through a completely separate discussion on configuration management. So that was second question. What was the first question? It was
how do you migrate legacy data against the reference standards when they might have local utility?
So that's a good question. Yeah, because in some cases the legacy system cannot cater for just using a national set. If that is the case, then what would happen as part of our process, you know, that be picked up as a business process issue. That might mean that we would then extend through either configuration management or some other means. We would have to extend our national set, not our national set, but we would have to add to that national set. But we only do that in the select few cases where we need to do it. What we're trying to do is work against the national set for everyone. So it's not the norm, but it's something we would, if we had to do it, we could do it.
And are those, sorry, the file specs that you talked about,
yes.
Obviously the ideal is that those are consistent across all of your migrations, that every health organisation migrates against a common file set. But presumably, as you do these migrations, you come across use cases that are new, and you have to add or
yeah. So a few things. One thing I didn't mention was the target Lorenzo scheme is additive. We call it additive because we never delete any data fields. So at the end of every table, we add additional fields which are nullable. So the schema itself is additive. When we're developing Lorenzo at an application level, anything that changes within the data schema is fed in via the application team into the DM team that manage the IFF specifications, and those IFF specifications are maintained and uplifted for each and every release. And then what happens is our tool sets, our mappings are auto-generated directly from those specifications. So alignment of our application development team with our data migration IFF file specification team means that we keep the tools in line as new changes are coming in. And we might go to, you know, as we start looking at new clinical data, we might be extending the data sets as well. So for instance, if we've never looked at mental health and this was the first time, we would have to develop some mental health data sets. You know, so I think it's probably worthwhile moving on to the next one now. I mean, any other questions we can take at the end. So validation as a service, I want to be really quick about this. So this is data quality. So data quality was an issue to us. What used to happen, if I go backwards, is CSC used to do, or do these trial loads, but what used to happen was the health organisations would take some of their poor quality data, throw it into data sets for us, throw it over the fence to CSC, and then we would run through the trial load. And as you can see, the trial loads take quite a while to do. And what happened is we'd end up just getting poor quality data all the while, thrown over to CSC, and we'd have 15, 16, 17 of these trial loads constantly passing the errors back. First of all, that was quite slow because all of the files were securely transferred, had to be picked up by CSC, loaded, the reports then had to be securely passed back. Quite time consuming. The trust, the health organisations didn't have, weren't empowered to do anything and speed that process up. So that was the first thing. The second thing was it was actually quite costly to CSC because we had a lot of resources that were constantly doing this. So what we decided to do was build a service which allowed us to, that's the slide I was after, build a service which would allow the health organisations to actually build their own data sets and immediately validate them. and get them to a level of quality where they could actually throw them over the fence to CSC. And as we said before, the data quality is poor because data types weren't enforced, check constraints weren't enforced, data usage and content, different health organisations used for the same field for different types of activity, and there was no standard for reference data. Previous historic migrations and initial releases of applications were causing a lot of data issues. So what we did was we had to work out, we wanted to develop a tool which allowed the health organisations to validate their own. And it was some very easy objectives. We wanted the tool to be very easy to use. So when you actually look at the tool from an application point of view, it's just based upon functional area. I know I said we've got 250 data sets, 20 functional areas. They can just choose the functional area that they want to preload, validate or load, and they choose it. They can choose multiples of that because we have a queue management system there which says I want to choose preload, patient, referrals, inpatient, outpatient, and there's an order in which all of these data sets have to be loaded so that there's no, so that all of the integrity is kept in place. It also had to be fairly secure, so we built it in our data centre, but we allowed multiple health organisations to connect to it at the same time to transfer their own data sets and then access the application to validate them. We didn't want any of those health organisations to see one another's data, so it had to be fairly secure as well. And when I say enforced licensing constraints, all that really was CSC we have contracts, licensed contracts with SQL Server, with Microsoft for SQL Server, etc. The health organisations aren't part of that contract. Therefore, we had to make sure that they touch the application, but they never touch the back-end systems. So they can request that the preload validate load was being actioned, but they couldn't get into the back-end service to touch those other products. So the health organisations can create and they can transfer and validate their data sets, and you get an immediate, there's a latency of about 20 minutes, but you get a set of reports back as soon as the validation completes. It's all done over SFTP, so it's securely done and it's encrypted. The reports are easy to drill into and look at. And what we also did, the last line, provide a standard application where there is no enhancements and manage for a simple configuration. If we start adding additional data sets or changing the Lorenzo schema, we don't want to go back to the application and start changing it. And so through configuration, we were just able to extend the application. Here's a quick diagram. So validation as a service was only developed for our non-hosted health organisations, so people who've got the KES and passes or other passes that weren't sitting out in our data centre. What it does is it allows them to create their data files, so the 250, in a defined order. Patients always, local reference data, patients, referrals, inpatient, outpatient, etc. Create these, securely copy them, log into the validation as a service application. Is it me or does that keep going yellow? Log into the application, invoke a preload and a validation, and then potentially also a load into Lorenzo. These validation rules are auto-generated, so the mappings are kept in line at the back end. Every time we have specification changes, we can regenerate the mappings to keep this all in line. So there are 3,000 validations that are applied to the data at this level, and you get reports back. So you go around this process, allowing the health organisations to simply copy the data, queue up the request to validate the data, switch the machine off because it's all done in the background. When they switch the machine on the next morning and bring the application up, because it's state driven, it gives you the information associated with completions, failures as well. And that just meant that what we could do is the health organisation could basically generate their own data files and validate those, and then throw them over to CSC when they were good to go. And the hope was that would reduce the deployment timeline from 9 to 12 months down to potentially 6 months. And that is validation as a service. So, and it's just an offering that we've put together that some of our health organisations are starting to use now. So I don't know whether anyone's got any questions about that.
Is it reducing the process time?
It is, yes. It is. So it's actually working. It wasn't only there to reduce the processing time, it was there to actually reduce the cost on CSC as well, because we hadn't got the resources to do all of that work. So, and it is working.
So when the organisation does evaluation and finds that there are lots and lots of records that have problems,
Yes.
are you able to prescribe some quick fix where they don't actually have to get more information by phoning up patients and so on, but they can do some simple thing that will just get it through?
It all depends on the type of issue. So if it's a source-related issue, occasionally it might be that it's just a reference data issue. So you would add an additional field to the reference translation table. Yeah, you're missing a postal address type out of the reference data. So we'll look at the fails and therefore it generates the errors. So it's a reference data update, or it's a mismatch in specialty against the national codes. However, if it is actually the source data that's wrong because a lot of the fields are null, yes, we can work with the hospitals. We can create default values so that the next time it runs through, they get a lot less errors. There have been occasions where, the health organisations themselves, they employ IT specialists and database administrators who go in and they actually update the data, to correct potential issues. So it all depends on what the error types are, but we don't give them the tool and provide no assistance whatsoever. We do support them with this process because there will be tweaks that are made to the incoming data, which can benefit greatly. Next, then, reporting services. So I've set a practical design question mark. Reporting differs for all different clients. I'm going to give you a flavour of what we do, but there are lots of different questions that different health organisations ask. What do we do? So from an operational reporting perspective, we have a number of canned reports or operational reports, which are a number about 200, 250. And these, at the moment, they now run on the live system itself. They are effectively real time in that they give you the snapshot, the view of the data as it is now. So they give you the ward list, the clinic list, but it's as it is now. No historic data, it just gives you a list, a report, so it's just effectively an extract of what's on the live system. It might be that, you yourselves have report servers and you replicate the data over to a report server and then you run the reports against the report servers. And that might be because running these operational reports on a production instance might have a detrimental effect. We've found, because Lorenzo is such a large beast in terms of CPU and processor power, it has very, very minimal effect on the system. Second is decision management and analytics reporting. So this is really, this is data warehousing. This is looking at the historic data for trend analysis. So what has happened? So it's as we say, it's data warehousing. Normally the feeds into this are normally 24 hours behind. So from CSC's point of view, we will provide generic extracts out of the system every 24 hours. Those generic extracts get loaded into a data warehouse, and then the decision so built into a common health schema, and out of the back end pop some multi-dimensional objects, relational tables against which decision management reports are run. So again, it helps with operating room and theatre efficiency or management performance scorecards. So looking at things like ward occupancy. Why are the wards only 60% occupied over monthly periods? It might be because someone's cleaning the beds and they're taking a hell of a long time to do that. But that is trend analysis. We actually we work with third parties a lot of the time to actually generate these decision management reports. So we're not actually building our own data warehouses and doing that at the moment. We're working with third parties because they already have the health information models there to use. And the third one is predictive analytics. So what's going to happen? We're going to cover a little bit of that later, but this is still in a relative state of immaturity. Not a lot is happening in this space at the moment, but a lot of companies are are now starting to build on this at the moment. But we'll talk about that in the next set of slides. Right, now that's a messy slide, that is, but it was just to try and build a picture of, so on this side we might have Lorenzo, we might have 17 ISOF patient managers, we might have many care valence systems, many patient centres, so those are all CFC systems, many of them. If we're running, so typically, if we consider this as the data warehousing side, then you might have data feeds into that data warehouse. They might be messaged in, they might be extracts which are then loaded, ETL processes migrated in to this data warehouse. You might also have federated solutions whereby, and it might be that the client has said, you're not taking my data into your data warehouse, we want it on-premise. Now, one thing I didn't mention is that because we're looking at global healthcare, we're also looking at Lorenzo on-premise solutions now. So we're not just looking at the strategic instance where we're migrating all of the healthcare data into one strategic instance. We actually can place individual Lorenzos on-premise. But it might be that the clients have said, you can't take my data, but we want to analyse that data and make some sense out of it and add some value from it. So we may use a federated solution which goes and grabs certain pieces of aggregated data through result sets and then brings them into a solution where it gets transformed and aggregated for delivering some results. So, messy slide, but in terms of what I wanted to make from a discussion, the operational reporting, that runs on the source system, on Lorenzo generally. From a data warehousing or decision management point of view, it'll run within this hub. But there are many challenges to get the data into this hub, which we'll come into in a second, from a decision management reporting. But at the end of the day, the biggest thing, the advantage that clients see is self-service reporting. So if you think of this as a general design for reporting, what we want to do is we have this health information model sitting in the centre, which is based upon, let's say, the NHS data dictionary. It's a standard schema with a standard output and a standard set of reports. These reports are either, well, not reports, objects, relational tables, multidimensional tables. If that were the output, what the client could do is plug in their own reports engine. Plug in their own reports engine, and based upon that reports engine, they could slice and dice this data however they want. We would like to keep that static, even though we start to add additional systems in and extend the volume of systems, keep that static. So the best design is to actually build some connectors on the front, which allow us to plug into the input, but keep the output the same. Therefore, we're always delivering the same reports out of the back end, whether it's a federated system or through a data warehousing solution. And then what we've got is we've got predictive analytics. Now this model doesn't really show the predictive analytics side because it's not dealing with things like structured and unstructured data, it's not dealing with real-time, CEP type processing. So we'll leave that for the next set of slides. But what are the challenges that associate with those? So the operational reporting, the data warehousing, and the federated solution. Just to take a few data import considerations. If we build a data warehouse and we've got 100 million patients across the globe of CSCF in many systems, if we start to bring that data into one data warehouse, the challenges with not only data import and association of those feeds and maintaining those feeds against schema, but also the data growth and how we keep that data and the processing power needed to actually deliver useful data out the back is a challenge in itself. Data residency is also a challenge. A lot of our clients, especially globally, are saying, you can't take our data, we want to stay on premise. So because of that, we have real data residency challenges, we aren't necessarily able to bring the right data in, and that's where client engagement comes into play as well. So that was just a bit on reporting services. I know there's a lot there. CSC don't deploy all of that, and we work with third parties to do the data warehousing side. But I just thought I'd put that set of slides there because there might be some interest and questions generated from it. No. Okay. Right, okay, so moving on to healthcare, analytics and big data. From CSC's point of view, well, from many companies' point of view, as we've said, this is a fairly immature area at the moment. There are specialist companies who deal with healthcare analytics and big data. CSC started looking in this space probably 18 months ago and building up the skill set roughly 18 months ago. But in the last 6 months, they've actually purchased a couple of big data companies to help us to grow in this space. And I'm not a specialist in this area, I'm trying to pick it up myself at the moment, but I just wanted to run through a little bit about where we're going with our coordinated care offering. Be about 10 minutes maximum? Yeah, okay. Okay.
The wine is outside, I've just seen it.
Sorry?
The wine is outside.
Oh, all right, okay. Okay, so in terms of where we want to go in the future, you know, the market demand is that for reform is basically threefold. We need to improve the outcome and safety of patients. We need to reduce the burden on diseases for population health, and we need to cut costs, basically. So
that's easily done.
Yeah. So that challenge, all challenges in their own right. I won't go through the rest. So where are we? If we look at healthcare and big data, so 18 months ago, someone asked me to look at Lorenzo and the solutions in the UK that we have at the moment within CSC and map that to a big data solution. And it was very difficult to do it because if you look at each individual hospital, a lot that, you know, big data is based upon volume, variety, velocity, size, you know. But typically, when we're migrating hospitals, they've got 60 gigabytes worth of data that we're migrating, 60, 80 gigabytes. It was difficult to work out how that could be classified as big data. And at the moment, there's not a lot in the unstructured space within the UK. But if you actually look outside of what you've got within CSC with the systems we've got, and you start to look at genomics and other areas, then you can see how you could grow this into a big data type solution. So we need to, from a big data point of view, try to align the structured and unstructured data. So we haven't got a lot of unstructured data at the moment in the systems. In the systems that CSC has migrated through into Lorenzo. There's not, you know, they say 80% of the data is unstructured. Yes, it is if you look at Facebook, you look at Twitter feeds. Yeah, we have got picture archiving, so we have got X-rays and things like that. But in terms of what we've migrated into Lorenzo, a lot of that is patient administration data, and most of it's structured at the moment. But when we start looking at the unstructured, there are questions I can't answer because I'm not an expert at the moment, but you think of questions like, you've got various types of text analytics tools that allow you to define templates against unstructured data, therefore extract data. But, you know, templates, you know, a patient name might appear in different places within a document. And if it says, if you pick up Fred Bloggs and you pick up diabetes, so therefore Fred Bloggs is diabetic, but the document actually says the daughter of Fred Bloggs is diabetic, you can get wrong relationships from the data. So it is a challenge in that area. But if I look at CSC and where we are, if we combine everything that we've got, as I say, at the moment, we've got over 100 million patient records that we hold worldwide because our systems are, you know, especially in America, Australasia, huge. So we have in the order of 60 different healthcare solutions. Obviously, we can't pull all of that together.
Is that what the national programme was about?
No, well, no. The national programme, yeah, was about trying to bring the 60 million patients together in one single strategic instance.
Too big.
It was changed. It was that was the aim. Was through CSC, Essentia, and Fujitsu was to try to bring this together into a strategic instance. The contract's changed several times since. We won't get to that state. But in America, we have a large number of healthcare solutions, and the restrictions on data, patient sensitivity, is less than it is in the UK, and it's less than it is in other places like the Netherlands and Germany. So it might be easier to amalgamate some of that data together. But if we look at what we're trying to do with coordinated care, we've got 100 million patient records. Yeah, that's globally. We won't be able to bring all that together. We'll bring a portion of that together. It ranges across a number of areas. Acute care, payers, life sciences. Life sciences being one area which is probably a significant area for big data. So that's really about scientific studies, biomedicine, biochemistry, generating new drugs, helping with life generally. We've got vertical streams, big data, cloud, cyber, various applications. What we're trying to do is work out how we can start to bring that together and provide some kind of larger big data solution.
You should have new people on that benefit system they're struggling with, so the service not.
I have no idea.
IDS is stuff.
Yeah. So what we're trying to do is work out what is the best solution to deliver a big data. And we're analysing, 450 different systems at the moment, trying to work out what is the best platform and set of processes and products to house this on. But if you think about it, we've got all of this patient data, we feed in some genomics, some utility company data, payers, providers, life science information. At the end of the day, what we've got to do is we've got to try to generate some useful data out the back end of it. So use analytics to uncover hidden patients with chronic diseases, or identify patients that would be very useful in clinical trials. But it's a challenge, and it's not one I actually know much about. We have, within CSC, we have big data teams that are actually working on this at the moment, so I'm just giving a flavour for it, that's all. If we look at the drivers, what have we got at the moment? So we're trying to improve the usability. We've got changes where we're going from desktop, we're going to smart cards, smart devices, we're going to tablets, so we need to change the way in which we're doing bedside administration, etc., etc. If we take that and we try to plug that into our coordinated care offering, what we're really trying to do is provide a variety of consumers a single view of that patient data, bring it all together, provide that, standardise it, and connect a load of people to it. And effectively, what we can then do is make use of it. And as a practical example, one of the things that we're doing is you've got your coordinated care engine, you've fed all this data into it, you've also fed in things like patient community information. So this is for identifying readmission risk. So in the current system, where it's just a data warehouse, how do you do that? You can't really identify whether a patient is likely to be readmitting. But if you feed some additional community-based information into it, so for instance, this patient is elderly, can't look after themselves, or just generally can't look after themselves. If you know about that, then when you discharge them, if you can make that association and inform social care, social service, social care, then maybe you can get some action which prevents that readmission because they're looked after through a trigger in some way. And that's the type of thing that they're trying to do at the moment. I've lost my way a little bit with that because that's not my area of specialty. But that's really it. So just in summary, we touched upon data migration, validation as a service, foreign services, and healthcare, analytics and big data. So unless there are any questions.
I'd like to join me thanking Steve. Got a small gift from the BCS for thanking for his efforts. So